Hello, in this video I will be solving a system of equation using Gaussian elimination. So this system we have in here is 4x minus 3y plus 1z equal negative 15 minus 2x plus y1 minus 3z equal minus 15, 1x minus y plus 2z equal 9. So here we are rewriting all the coefficients as augmented matrix in here. And so to solve a system using the Gaussian elimination, we're going to have to use a few steps. Step 1 is try to eliminate minus 2 to 0 and 1 to 0, because we need the first column to be 1, 0, 0. That's the first step. The second step, once you have 1, 0, 0 in the first column, the second column should be 1, 0 in here, and these letter squares here, meaning it could be any number. And the third step is just you have any two numbers in the third column, but the last one should be 1. So here, as we said, the first column need 1, 0, 0, and it doesn't matter which one first in this case. So I decided to take the first column, third row, to make this number here 1, make it a 0. So it says here I need a 0. So here we need a 0. So for 1 to be 0, if I have 2 times 1, that's 2. 2 minus 2, that will make it a 0. So the coefficient I choose is to multiply 2 R3, that means the row 3. I take the whole row 3 and multiply it by 2. I'm going to add it to row 1, and that will give me a 0 here. So let's see. 2 times 1 is 2, minus 2 is 0. And then 2 minus 1 is minus 2. Minus 2 plus 1 is minus 1. 2 times 2 is 4, but 4 minus 3 is 1, which we have here. And 2 times 9 is 18. 18 minus 15 is 3. So here I did change this third row, become 0, minus 1, 1, and 3. And the rest I'm just going to copy them as 4 minus 3, 1 minus 15. And minus 2, 1, minus 3, minus 15. So I copy them, that's why in green color I didn't change anything. Whatever I change, I keep it in red. So again, follow this first step here. We need 1, 0, 0. So I'm gonna make sure minus 2 is a 0. And to do that, if I have 2 times minus 2, that is 4, and add it to 4. So I have to add it to some opposite to make it a 0. And it's opposite number. I can add it to 0, because if you add anything to 0, it's like nothing changed. That's the identity for addition. So 2 times a minus 2 is 4. 4 minus 4 plus 4, that would give me 0. And 2 times 1 is 2. 2 minus 3 is minus 1. 2 times minus 3, minus 6. And minus 6 plus 1 is minus 5. 2 times minus 15 is minus 30. Minus 30 and minus 5 is minus 45. So here I change it in different color. But the rest I just gonna copy because we didn't make any changes. And again, keep this in mind. Step 1, I need 1, 0, 0. So far I have 0, 0, but I don't have a 1 here. To make this a 1, I have a 4. So if I divide by 4, or multiply 1 quarter, it will change 4 to 1, and that's what we did. R1 divided by 4, and you move it to R1. That's going to be my new R1. R meaning the row 1. 4 by 4 is 1, minus 3 over 4, 1 over 4, minus 15 over 4. So I change it, it's in red, and I copy the rest of the rows, because I didn't do any changes to them, not yet. Now I'm done with my first step, which is 1, 0, 0. The second step is that I need some number, but I need these two to be zeros. So I'm going to make these two to be 1 and a 0, not 0. So I need a 1 here. Following this step, I need a 1 and a 0. It's easy to make this a 1, it's just by dividing or multiplying it by negative 1. That's what we did here. 0, 1, 5, 45. And for this, and I copy down the two other rows. And the third row, to make this a 0, I'm going to add R2 plus R1, because 1 minus 1, that will give me 0. So I'm just adding these two rows. 0 plus 0 is 0. 1 minus 1 is 0. 5 and 1 is 6. 45 and 3 is 48. And then the changes is in red. Copy down the other two rows from the last step. Okay, so again, I'm done with the second step, which is a number 1 and a 0, a number 1 and a 0. And here I have 1 0 0 1 0 0. So the third column I need to have two numbers, doesn't matter what they are, but the last one I need 1 here. Well, I have a 6. To make a 6 equal to 1, I just have to divide by 6. Divide by 6. So if I divide by 6 here, here, and here, and here, it's gonna be 0 over 6 is 0, 0 over 6 is 0, 6 over 6 is 1, 48 over 6 is 8. And we are into step 3. So we could stop here and then use back substitution. So here I have x plus minus 3 over 4y plus 1 over 4z equal minus 15 over 4. And second step I have y plus 5z equal minus 45, and here I have z equal 8. So I have one value solved. Z is 8. So the next step I do is just take z equal to 8 and substitute that in the next second equation. So you have y plus 5 times 8 equal 45, and which is y plus 40 equal 45. That tells me that y is 5. Now we solve the second variable, the unknown. So we have y and we have z, or what's left is x. So now I'm going to substitute both of them in the first equation. So we have x minus 3 over 4 times 5 plus 1 over 4 times 8 equal minus 15 over 4. So we have x minus 15 over 4 plus 8 over 4 equal minus 15 over 4. I put 15 here. So as we see, minus 15 over 4 from both sides can cancel out by adding 15 over 4 to both sides. And we have x plus 8 over 4 equals 0. 8 over 4 is 2. That means x plus 2 is 0, which tells me that x equal minus 2. So here is the third variable. So we solve the system as minus 2, 5, then 8. And that is the solution to this system using Gaussian elimination. And I hope